All right, guys. So please do try this question based on averages. All right. A class consists of 20 boys and 30 girls. In the mid-semester examination, the average score of the girls was 5 higher than that of the boys. Okay. So we'll assume the average of the boys as X. The girls will be X plus 5. So can we calculate the combined average? 20 into X plus 30 into X plus 5. Divide by 20 plus 30, 50. So this will become 20x plus 30x, 50x, 30 into 5, 150. The whole thing upon 50. This is x plus 3. So initially the combined average of both of them is x plus 3. Right? In the final exam, however, the average score of the girls dropped by 3. So now, presuming the number remains same, of course, otherwise you can't solve the question. The average score of the girls dropped by 3. So the new average score of the girls is x plus 2, while the average score of the entire class increased by 2. So now the entire class's average is x plus 5. Then increase in the average score of the boys is. So let us assume the average score of the boys currently is y. All right. So we can use the weighted average 20 into y. Okay, 20 into y plus 30 into x plus 2. Divide by 20 plus 30, 50 will be equal to the average. So 20y plus 30 into x plus 2 upon 50 should be equal to x plus y. Taking 50 on the right hand side, we will get this. From here, we can calculate the value of y, right? 20y plus 30x plus 60 is 50x plus 250. So basically this will give us 20y is equal to 50x minus 30x is 20x plus 250 minus 60 will be 190, right? And that gives us y as basically divided by 20 everywhere, x plus 9.5. So now the new average of the boys is x plus 9.5. The initial average of the boys was x. The final is x plus 9.5. The increase is 9.5. Right? The same question can be solved very easily, guys, if we use the method of deviations. Let's see how. So initially there are 20 boys and 30 girls. Average score of the boys is x and the girls is x plus y. The overall average we can find by using deviations or the assumed average. Assume the average as x. Now this group has an extra 5 and there are 30 such people. So we have an excess of 5 into 30 that we divide between all the people equally. 20 plus 30 will be 50. So basically this is tens and basically threes. So the deviation is plus 3 from the average. That means the actual average for all of them is x plus 3. Similarly now, the overall average increases by 2. So the new average is x plus 5. Number of boys is same, the girls number is same. And the average score of the girls dropped by 3. The average of the girls is now x plus 2. Now, we observe that every girl has a deficit of 3 from the average. Like that, there are 30 girls. To compensate, we must have the same excess with the boys. Plus 30 into 3. Okay, and that will be contributed by 20 such boys. So every boy basically contributes an excess of 3 into 30 divided by 20. This will be 4.5. That means the average score of the boys has an excess of 4.5 from the average. So the new average score of the boys is x plus 5 plus 4.5, x plus 9.5. So the increase in the average score of the boys is 9.5, option A again. A much simpler way as compared to using the total method. Using the method of assumed average or deviations, you can solve this question very, very quickly.